Alright, yesterday we talked about three of our properties of parallelograms. At opposite sides are congruent, opposite angles congruent, and consecutive angles add to 180. On the back, we're going to add one property and then one thing that kind of follows from the other properties we've talked about. So the first one says that if we have a parallelogram, diagonals bisect each other. Okay, so again, a couple words we have to make sure we know what they mean. First, what's a diagonal?
An escalator goes diagonal. That's the only thing I can describe it.
So, I mean, normal, like just in everyday lingo, you say like a slanted line or something like for a diagonal. Right? Our actual math definition of a diagonal is a line that connects non-consecutive vertices. Okay, so what that means is we have our parallelogram A, B, C, D. So if I draw a line to connect two of the vertices that don't already have a side between them, that line is called a diagonal. Okay, so here, BD and AC would be diagonals. Right? So this says if we have our diagonals drawn in, they bisect each other. What does bisect mean? Go through. They would cross in a specific way. Oh.
They run into each other.
Yeah, they run into each other, they cross, but in a specific way.
Think about when we do proofs.
I know. Does it have something to do with like them being like equally or congruent?
Say it louder, Zoe.
Yeah.
It cuts something in half.
Yeah, right. It cuts something in half into equal pieces, into two equal pieces. Right. Bi means two, so bisect means to cut into two equal pieces. Right. So if you want to make a note, what bisect means, cut into two equal pieces. Right. So we're saying if I draw in these diagonals, they cut each other in half. So what we could say then is those halves are equal to each other. They're not all four equal. It would just be like here I could say DP and BP have the same length. And then I could separately say AP and CP have the same length. Okay? So if I know that DP is 6, then EB is 6. If I know AP is 4, then EC is 4. Right? That's what we're saying here. They're not all four necessarily the same length, but each half of one of the diagonals is going to be equal to the other half. Right? The other property that's listed here just kind of follows from some of the things that we talked about yesterday. Each of the diagonals cuts a parallelogram into two congruent triangles. So if I just draw one of the diagonals of a parallelogram here, well, one of the things we talked about yesterday is that opposite sides are congruent. Okay? And then also opposite angles are congruent. So if I just say that this one pair of angles is congruent, I can already say that these two triangles are congruent by side, angle, side. Okay? So what that means then is every piece that's inside of these has to be congruent. So this angle would be congruent to this angle here would be congruent to this angle here, and then obviously this diagonal would be congruent to itself. So that helps us find maybe a few more pieces if I know that the diagonal cuts the parallelogram into two congruent triangles. Okay, and it would work the other way as well. Right? If I just drew a diagonal here, these two triangles would be congruent to each other. Okay? So we can use those ideas to set up and solve some problems. Right, in this first one, it just says find x and y if we know this is a parallelogram. So parallelograms, we know the diagonals bisect each other. So each half of the diagonal here would be equal to the other half. And so I can say that AE is equal to EC. So I can set up an equation for y to say 4y equals 18. To solve for y then, just divide both sides by 4. And we would get y equals 4.5. Do the same thing then for the other diagonal. Those two halves will be equal to each other. So I can say 6x equals 24. And again, all we would need to do to solve for x here is divide by 6. We'll get x equals 4. Okay. Questions? All right, let's try a couple of these here. Let's just do 1 and 2 right now. Take a look at 1 and 2 here. So on right, but so
So I think y equals 28 4.
How's louder?
Did you just say a fire drill?
I said it sounds like a really weak fire drill.
Sit. You're crazy.
I think that 4x equals 20.
I just think that's what
Well, one up that window. Funny how we that one put in this. I don't know why we should have them open. Be able to. I just don't know why they put that many windows in that.
We are not.
They're not against their neighbors. If there was a threat every 2 codes, all they have to do is drive down the road at 60 miles an hour. Later.
I'm saving green shade.
Especially if they have someone hold a fire line and everybody goes down
One thing is, you would care about that. Well, I do that. That's not bad. I wouldn't expect you to. I wouldn't expect myself. Yeah, I'm
it's x equals 4 and y equals 2 for number 1, and then x equals 7 and y equals 14 for number 2. Okay, the only maybe difference is that on number 2, we are told that these two pieces of the diagonals are congruent, which ends up meaning that all 4 halves of the 2 diagonals would be congruent in this case. That's a special case, right? Normally it wouldn't be that all 4 pieces are the same. It would just be each half of each individual angle is equal to the other half. Right? Questions? Okay, so some of these other examples on here actually get into things that we're not going to cover until later, like we would have to use the Pythagorean theorem for one of these, and we would actually have to know properties of a rhombus to do another one of these, which we're not going to talk about until a few more sections. So I don't know why these are on this note sheet. Okay, but the big thing that we're looking at here is just diagonals bisect each other, right? So we are going to jump down and take a look at the coordinate ones, though, right? So these two problems were given all 4 coordinates of the vertices of a parallelogram, and it says find the coordinates of the intersection of the diagonals. Well, if I know that the diagonals cut each other in half, they bisect each other, where would they meet? Sebastian? Okay, so that would maybe be the answer.
You're asking the general. Okay. They meet like the 2 vertical, 2 diagonal like this.
Yes, the 2 diagonals would meet where the 2 diagonals meet.
I mean, I don't.
Yes.
That's not what I mean.
So there are a couple of ways of figuring out where the diagonals would cross. Right? One of them could be to just graph these 4 points, draw in the diagonals, and see where they actually intersect. Right? But another way of thinking about this is
I see.
if they're cutting each other in half, we want that middle point. Okay, we want the point that's exactly halfway in between the vertices. Okay, so I'm just going to sketch a generic parallelogram. This isn't what these 4 points would look like. But if I want the point where the diagonals intersect, okay, the point right in the middle, what I'm doing is finding the midpoint between opposite vertices. Right? So if this is A, B, C, D, okay, the point where these intersect is going to be the midpoint of either AC or the midpoint of BD. Okay. Do you remember how to find midpoints? Okay.
Don't you gotta do that y1 x and like the y1 y2 and the x1 x2? So would it be, or this one, isn't it? Y minus the y1 and then something else. I forget.
Yeah, I think you might be thinking more of the slope one. The midpoint one's kind of similar, but this is the one where we take the average of the x coordinates and the average of the y coordinates. Okay, so I add the 2 x's together, divide by 2, and then add the 2 y's together and divide by 2. Okay, so if you remember, I mentioned this yesterday. We said the way that this is written tells us the order that vertices go around a figure. So A, B, C, D, they go in order around the figure. So that tells me that AC would be a diagonal and BD would be a diagonal. So I want to find the midpoint of opposite vertices. So I'll do A and C. Right? I can make this one my x1, y1, and this my x2, y2. So if we plug that in here, we'll have 3 plus 3 over 2, and 6 plus -2 over 2. So we'll get 6 over 2 and 4 over 2, which would just be the point 3, 2. Right, so what we're doing is finding the midpoint of a diagonal. The other way that we could do this is to put this information into Desmos. Okay, I can type in those 4 coordinate points and then draw in the diagonals, see where they intersect. Okay, so let's practice that real quick here. Okay, let's put this into Desmos and see what it looks like. All right, so we've got 3, 6, and 5, 8. Three, -2, and 1, -4.
Midpoint is a formula, let's get it right on that air test. No. So it might be a good one to write down, guys. The star next to.
Alright, so if we put that into Desmos, this is what the figure would look like. Right? So one thing that I've mentioned, okay, when we're using Desmos, if we want to connect points, right, I can put them all in the same line like this, with just a comma in between. So I put in all of those points with a comma in between each point, and that'll connect the coordinates. If I come over to the left side here, okay, this icon right here, if I click and hold that, it'll give me a few options. Okay, here is how I would turn those lines on and off so that it actually looks like a parallelogram. Okay, so then I could actually do the same thing and then connect opposite sides, or opposite vertices. Okay, so if I wanted to connect 3, 6 and 3, -2, I can type them in here to a line, hold this down, and draw the line in between them. Then I could do the same thing for the other pair of opposite vertices. So I can type in 5, 8, and 1, -4, come over here, and turn that line on. Then I can see that those diagonals intersect at this point right here, which would be the point 3, 2. Alright? So for a problem like this, okay, we're either thinking, well, I want to just calculate the midpoint of a pair of opposite vertices, or I can put this information into Desmos and actually see where those diagonals cross. Okay. Questions on something like that?